This video will go over problems involving interest, compound interest, simple interest, and compounding interest continuously. The formulas that are in this video are the compound interest formula, where you start off with a certain amount of money, that's your principal, and you have a final amount of money, that's your stopping point. And then 1 plus r over n, your rate of interest as a decimal, and your number of times you compound, the number of times you figure out interest in a year, and then n is repeated, and then t is the number of the time in years. The compounding continuously formula, you start off with a starting amount, and you have the interest rate as a decimal, time, and the final amount. Basically, this is y equals a b to the x. There's your starting amount a, so you start here, you start there, you stop, you stop. Your b is this part right there, and then the number of times it changes is the x. So these two are the same formula, but this one is specific for money. Over here it's a little bit harder to see the connection. The b is wrapped up in this e business because it's changing so much many times, and then the x matches, and then the starting point is the a, and then the a is the output there. Okay, so here we go. We're going to compare the different types of interest here. This is simple interest formula. So you have $1,000 as your starting amount, so amount is equal to 1,000 plus 1,000. The rate of interest is 5% as a decimal, so for 5%, and for 4 years. So you find the amount of money in an account after $1,000 has been deposited for 4 years at 5% interest. So your starting point is the $1,000, 5%, 4 years. You type this into the calculator straight up, just type it in the way it looks, and you get $1,200. The next is asking for the final amount after you do the same thing, but it's compounded monthly. So it's still $1,000. It's 1 plus the rate of interest is still 5%. So we're just kind of comparing the things here. And then monthly means you're figuring out the interest 12 times a year. So n is 12, and to the 12 does the ends match, and then for 4 years. Now when you type this into the calculator, I would just switch that up to 48 right away. So you're figuring out the change 48 times. We type this into the calculator, and you should get a little bit more because you're getting interest.
Victoria Murray to the attendance office, please. Victoria.
So we type this in, we get a little bit more money because of the compounding of the interest. You're getting interest upon your interest. It's $1,220.90. And then we're going to compare this to compounding continuously. So A is equal to $1,000 still. E is the Euler number. And then the rate of interest is still 5%, and we're still going for 4 years. And you type this into the calculator, and you get a little bit more money, but surprisingly, you don't get like huge amounts of money more. So it's $1,221.40. So by comparing these, we have $1,200 for simple interest. By compounding it, you get $20.90 more. And this always surprised me the first time I did this back when I was in high school, is the fact that by compounding it continuously, I was like, oh man, I'm going to get so much more money. But you don't. You only get an extra 50 cents because your changes are very, very small. So you're changing so small that you're not getting tons of money more, just an extra 50 cents on a $1,000 account. Now, if it was a $10 million account, then that would be a lot different, wouldn't it? Okay, now we're tripling money. And it says compounding quarterly. So by compounding quarterly, we're using the n business, so we're going to use this formula right here. So we have amount is equal to P1 plus R over n to the nt power. So it's $1,000 tripled, 5% interest, compounded quarterly. So my starting amount is 1,000, and I'm going to triple it, which means I get 3,000. 1 plus the interest rate, 0.5. Compounded quarterly, so it's 4 to the n t, so it'd be 4 times t power. All right, to solve this, I need to get t by itself. But before I do the log of each side, I'm going to divide by the 1,000. I get 3 is equal to this decimal. I'm going to type that decimal into the calculator. 1 plus 0.05 divided by 4. Now, I know in order to do this problem, I need to keep all the decimals. I'm not rounding to the end of the problem, otherwise it'll throw off your calculation. So I took this part here, typed into the calculator, got this. Now to bring down the exponent, we take the log of each side. And that gives me log 3 is equal to 4t log 1.0125. Keep all the decimals. Bum, bum, bum. I got double multiplication. So each one of these things is multiplied times t. So in order to solve for t, I have to do the opposite of multiplication twice. So dun, dun, dun. I got double division. So I'm going to divide by 4 on each side to get rid of that. And then I'm going to divide by the log 1.0125. Okay, and this cancels out. T is by itself. That's the exact answer. Now when you type this into the calculator, you have to put parentheses there. So you have to do log 3, close the parentheses, divided by, left parenthesis, 4, log 1.0125. Close the parenthesis twice, and you get 22.11 years. So t is equal to, approximately equal to 22.11 years. All right. So the key to this is it's the 4t comes down to the front. You got to solve for t. So you have double multiplication. So you're going to double divide. You're going to divide by 4, divide by the log. Okay, the next one is quarterly. We're starting with 2,000. It's growing to 3,000. There's my interest rate. And I have to figure out how many years it's going to take to do that. So it's the same problem. So $3,000 is my final amount. My starting amount is $2,000. 1 plus the rate of interest, 0.0575. It's compounded quarterly, so I'm going to divide by 4 again, to the 4t power. Same procedure, divide by the 2,000. And that's going to be 1.5 is equal to, and I'm going to type that into the calculator and see what I get like I did in the last problem. So it's 1 plus 0.0575 divided by 4. And I can keep all those decimals, or I can use the fractions. So let's see what it is as a fraction. It's 1,623 over 1,600. 6 of one, half a dozen the other. I'll use the decimals. 1.014375. Since it's a terminating decimal, I'm going to use it. To the power of 4t. Same thing as before. Take the log of each side, which brings the 4t down to the front. 4t log 1.014375. I got double multiplication, which means I'm going to do double division. I'm going to divide by the log 1.014375, log 1.014375. All right. This needs to be in parentheses just like before. Type it in just like before. It's log of this number divided by 4 times log of this number. So hopefully you type all that in correctly. That cancels out. That's gone. T is by itself. T is approximately equal to 7.10 years. All right. The next problem, you're comparing the two accounts again. You're comparing compounding quarterly in part B for 5 years, and then the same thing by compounding continuously. So this is a two problem here. So we got amount is equal to amount is equal to P1 plus R over N to the NT power. And we're comparing that to A is equal to PERT. It's the wash and go PERT formula, PERT and PERT plus. So it's $2,000. And we just want to know a final amount. 1 plus interest rate 0.045%. That's a decimal percent. So as a percent, it's a decimal percent. So as a decimal, it's 0.045 divided by quarterly, 4 to the 4, and then times, how many years is it? 5 years. So again, I would change that to 20. Type this into the calculator, and you get $2,501.50. Okay, now the other account would be the same amount of starting money, $2,000, and E is the Euler number, 0.045 interest rate, and then time is 5. Type that into the calculator, and your final amount should be $2,504.65. And the question is, how much more do you get? Well, you get an extra $3.15 by compounding it continuously. So comparing, this is just like number 5, you're comparing the two formulas and what happens to the money. All right, the next problem, we're trying to figure out how much money we should start with, because it says how much should be put into the account to get the $8,000. So it's compounded continuously, so we use the compounding continuously formula. And the final amount is $8,000. And we're starting off with, we don't know. The rate of interest is 5% as a decimal, 5.2%. And we're going to do this, after 5 years, we want $8,000, so T is 5. All right, this is a number, and this number is multiplied times P. So this number here is times P. So we're going to do the opposite. We're going to divide this number over. So I just have to divide each side by 8 by E, 0.052 times 5, 0.052 times 5. All right, so those cancel out. P is now by itself. I have to type that into the calculator. Let me type it in with you. This is a little bit different. So it's 8,000 divided by second E, and then it's just 0.052 times 5. Boom. So you'd have to put that much in to have $8,000. So principal is $6,168.41. All right. The next one is, how long does it take your money to double if you're doing continuous? This follows the rule of 72. So 72 divided by 8% interest would be 9 years. So according to the rule of 72, it's about 9 years. All bankers know the rule of 72, and you just take 72 and divide it by your interest rate, and it tells you how long it takes money to double. So the answer is going to be close to 9. A is equal to, compounded continuously, PE to the RT. We're going to double some money. We keep using $1,000, so I'm going to say your final amount's $2,000. It doesn't matter, because the first thing I do is divide over the 1,000, and then it's just going to be 2. E, rate of interest, 8%. And then how long does it take for that to happen, T? So we're missing the time. We know the rate of interest. Start, and we double. You can start with 10 and make it $20, because it doesn't matter, because your first step is to divide over the 1,000. So you get 2 is equal to E 0.08T. Then we're going to take the natural log of each side, which brings us down to the front. Natural log of 2 is equal to 0.08T natural log of E. The natural log of E is 1, which is why we use that. So all I have to do is divide over 0.08. And this is where the rule of 72 comes from, because the natural log of 2 divided by 0.08. The natural log of 2 is approximately 0.69, and you're dividing it by 0.08. So that means it's kind of like dividing 69 by 8. But bankers use 72 because it divides a lot easier instead of using 69. So here we go. If we type it in, see natural log of 2. So it's 0.69 and change, and then you divide it by 0.08. So it's t time is equal to 8.66 years, which is close to what I said, 9. The next problem is solving for time as well, and we start off with 200 bucks. We're compounding continuously. We end with $331.07. E is E. The rate of interest is 0.084 times T. So it's 8%, 8.4%. Starting, stopping, how long, looking for T, will it take for this to happen? So we're divide over the 200. Now dividing by 200 here doesn't work out so well, so I'm just going to leave that fraction. So we get 331.07 divided by 200 is equal to E 0.084 T. Take the natural log of each side, which brings the exponent down to the front. So it's natural log of this fraction, 331.07 over 200 is equal to 0.084 T natural log of E, which cancels out because it's 1. Divide the 0.084 over 0.084, and you get that answer. Type that into yield calculator, and it's like right at 6 years. All right, the last problem, and am I about out of time? Getting close on time. Let's see if I can get this done in 3 minutes. So this one is just like the one at the top of the page. We have a 325 is the final amount, and we want to figure out we figure out the starting amount because this grew for 8 years. So we have a final amount of 225 is equal to P. E rate of interest is 3.4%. That's kind of hard to read. So it's 0.034% for 8 years. Photocopies have made this go. That's 3.4% now. So this is a number. This gets divided over. So it's 525 divided by E to the 0.034 times 8. And that's equal to P. Type this into the calculator, and you get P is approximately 400 bucks. So it's $399.97. All right. So there's some problems with compound interest, continuously compounding, and compounding monthly or daily or hourly or whatever. Not hourly, monthly or quarterly.